In this series of videos I'm attempting to repair this Hazeltine 2000 smart terminal. In the previous video in this series we got as far as getting some characters to display on the screen. They were random characters that were in the RAM when we powered up the machine. So what we had was the clock generators had been tested and were working, the monitor, I'd installed the cards to produce the video output and the refresh control, and I then fitted the memory logic, memory control, and what was still missing was the input output. I'd fitted part of this because that had to be there for the display to work, but now I've gone ahead, worked my way through the rest of the cards, exactly the same process as before, doing static testing, looking for shorts, then putting them into the second chassis and doing some basic testing on the circuits as far as I could determine what the circuits were supposed to do. I don't have a full schematic for this, but I do have block diagrams for large parts of it. I've now fitted the keyboard logic and control, and from this point on it's important to understand the difference between this terminal and terminals you may have seen in the past. This is a smart terminal. I mentioned in the first video that I'd come back to what that was all about in future videos, and we'll start in this video. I'll give a very brief introduction to the difference between a terminal like this and a normal dumb terminal that you may have encountered before. If you're familiar with these, then you'll know what I'm talking about, but otherwise it can be very confusing when you try and work on these, and you can easily fool yourself into thinking they have faults when actually they don't. One interesting comment, or in fact two comments in the previous video, was that the memory at power-up seemed to be showing repeated patterns. Now in almost all terminals that would indicate that there was kind of a repetition in the reading of the RAM. So if there's a bit stuck, for example, then it tends to duplicate patterns, or depending on which bit's stuck or which bits are stuck, different portions of the block of RAM will appear to repeat on the screen. Now it's true, that's exactly what it looked like, but that's not what was happening in this terminal, and that's what I want to try and show in this video. So don't worry, there are still faults in this that I need to resolve, so we will be looking in more detail at some of the circuitry, and in the second of the two terminals I will go into more detail as to how each of the individual circuits work. But I thought it would be easier to do that once you've seen the entire system running, and I've explained in more detail how various aspects of it work. So at the moment I have all the cards now installed. I've worked my way through all of them, fixed a couple more faults. I think I found 3 more ICs that had failed. I've replaced those. I've also replaced the faulty IC I mentioned on the RAM card. One of the RAM chips had failed. So as far as I know, all the RAM now works. But I'm going to show something interesting that might initially look like the RAM is faulty, but I want to explain why it might not be. It's understandable if you're used to working on machines like this and vintage PCs and computers, that when you see repeating patterns on the display, it usually indicates a fault in the memory or memory control, where one of the bits, at least one of the bits, is sticking. So I'm going to move the camera so you can see the display, and then I'm going to power it up and we'll go from there. Okay, so I'll now power this up, wait for the tube to warm up, and we should see something on the screen as we saw before. So here it comes, and as you can see it does appear that we're getting repeated patterns, and it's easy to think that that is a fault in the memory somewhere. I'll just lower the camera and hopefully you can see this a bit more clearly. Okay, it does look like there is a repeated pattern, and it appears as if though there's at least one stuck bit in the memory system. And as I say, I've got all the cards installed, I've been testing them, so in theory a large proportion of this should now work. So I'm going to try pressing a key on the keyboard and see what happens. and hopefully you can see I'm pressing the G key and we're getting a G. I'll press the H key, pressing an H. But notice what happens as it goes past these next characters. I'll keep pressing the H key. Notice it's not replacing the character. And characters, I'm continually pressing the H key here. So notice it's behaving in a fashion that, to all intent, that beep is it's telling me I'm getting towards the end of the line. So I'm going to try pressing the carriage return, and it has indeed returned. I continue pressing the G key. So it looks, to all intents and purposes, like we've got an issue with the memory and there are stuck bits. But watch what happens if I clear the display. So I'm going to press Shift Clear. The display has indeed cleared. What I'm going to do now is continue pressing the G key. I haven't centered the display yet, as you can see. And I'm going to hold down the repeat key and hold the G key down. Now it would do this all the way down and it will fill the entire screen with this character or whatever characters I type. Which begs the question is, why was, I'm now pressing the H key, which begs the question, why was it not updating all the characters before? And that comes back to the smart in the smart terminal description. Normally when you have a terminal like this, whatever you type in is what's sent out to the remote machine, or what you send from the remote machine is put onto this terminal. But watch what happens if I press the Tab key. I'm going to press the Tab key on the keyboard, and notice that the cursor has now gone right down to the bottom right hand corner of the screen. The reason it's doing this, and the reason that the screen appeared to be faulty in the first place, is it's actually a problem with the reset. It's not clearing the RAM when the machine is turned on. This smart terminal effectively has coded characters, so each location on the screen, so each of the memory locations can be coded to be either what's called a foreground character or a background character. So what you can do if you want to with this terminal is create a form on the screen, and then and that would be a background made from background characters, and when you then type into the terminal using the normal mode using foreground characters, it kind of ignores the background. So it's like if you created a paper form, you can then jump between the fields on that form, and when you type it won't update the form characters, it will only update the foreground characters it's allowed to. And the same when you press Tab, it will jump between the allowable update fields that you've created with your form. So it's not a case of the memory's not working. This is doing exactly what it's supposed to, in as much as when it encounters a background form character, it won't update it unless you explicitly send an instruction to do that. I'll come to that in a future video as to how you create the forms and how this interacts with the remote machine. But that's why you were seeing a repeating pattern on the screen. It's actually just a mixture of foreground and background characters, and it does appear like the memory's not doing anything that it's supposed to. But that's exactly the way it's supposed to work. I'll recycle the power and you'll see what happens. So notice now it's got some residual G's in there just because the power wasn't off for long enough. But if we now just move the cursor down and I try doing the same thing again, notice that if I press the G key again, it doesn't need to be the G key, I'll press the A key, we're getting an A, another one, and now they're background characters, so it won't change them. But when we get to an allowable foreground area, it will allow the character to be displayed again. So that's the reason it kind of looks a bit odd, and that's something you have to bear in mind when you're working on machines like this. They don't necessarily behave in the way that you expect them to. But that said, we are now of course making very good progress. We've got to the point now where we can update what's on the screen. The keyboard isn't interacting nicely. It's not working properly yet, and I haven't tried the serial interface. I don't know if it's sending anything in or out of the interface. I don't know if the cassette interface works. I don't know if the printer interface works. All I've done so far is what you've seen here. As much as I can, I'm trying to show you this in real time, so I'm not jumping ahead and then coming back to show you retrospectively what I've done. The only thing I'm not really showing you is all the grunt work in working my way through the card. It's the same with every single card. I'm just testing each of the circuits as best as I can, determine what they're supposed to do, and then I'm installing them, running it like this, and what we can do now is start working our way through any existing faults. I haven't checked the manual. I don't know if it's supposed to automatically clear the RAM when you power it up. Bear in mind there's no processor in this thing as such, so certain functions that you might expect in a more modern system, such as clearing RAM, may not exist. It may not do that. I'll check the manual. If not, it might be a case of you have to clear it explicitly when you start the machine up, and then you type whatever you want and use it as a standard terminal. Or you can upload forms or whatever you want from the remote machine, or you can create the forms directly on the terminal itself and even upload those to the remote machine. It's a smart terminal, like I said, and the smart thing about it is also that when you send characters from the terminal, it can differentiate between sending foreground characters and sending background characters. So it could send, for example, just the text you've entered into the form and not the form itself. So very clever system. That's one of the reasons there are so many cards in this. It's quite a complex system, and as I said, that's something that you really need to take into account when you're working on these. Otherwise you could spend weeks trying to figure out why there appears to be a RAM fault, when in reality, as you can see, there isn't a fault with the RAM at all. So interesting comments on the previous video, and quite understandable, but once you're familiar with this, and as we work our way through this and go into more detail, then hopefully it will become much clearer as to exactly why it's doing what it's doing.